Hello everyone, welcome to the most important topic that we are going to see in entire NLP course, which is what is word embedding slash what are word vectors. So basically it is an approach for representing words or and documents. Word embedding or word vector is a numeric vector input that represent a word in a lower dimensional space. It allows words with most similar meaning to have a similar representation. They can also approximate meaning. A word vector with 50 values can represent 50 unique features. Then what are features? Anything that relates words to one another, example age, sports, fitness, employed, etc. Each word vector has values corresponding to these features. Now, what is the goal of word embeddings? So the goal of word embeddings is very simple. It is used to reduce the dimensionality, to use a word to predict the words around it. Interword semantics must be captured, as we know that we have just seen about the semantic comparison. So for that purpose also, for comparing the semantic analysis, we can use word vectors. And how are word embeddings used? So they are used as input to machine learning models. They take words and they give their numeric representation, and hence after they give their numeric representations, we can use those in training or inferences. So or another point will be to represent or visualize any underlying patterns of usage in the corpus that was used to train them. So perhaps this is why we need how we are using word embeddings or word vectors. So what are the implementations of word embeddings? So word embeddings are a method of extracting features out of text so that we can input those features into a machine learning model to work with the text data. They try to preserve syntactical and semantic information. The methods which are used are like bag of words, count vectorization, and TF-IDF rely on word count in a sentence but do not save any syntactical or semantic information. In these algorithms, the size of the vector is number of elements in the vocabulary. We can get a sparse matrix if most of the elements are zero. Larger inputs vectors will mean a huge number of weights, which will result in high computation required for training. Word embeddings give a solution to all of these kind of problems. So let's take an example to understand how word vector is generated by taking emoticons, which are most frequently used in certain condition, and transform each emoji into a vector, and condition will be our features. Now you can see in this picture happy, sad, excited, and sick. And the vectors, the emoji vectors for emojis will be happy, sad, excited, sick, and the respective values have been given. Now in a similar way, we can create word vectors for different words as well as on the basis of given features. The words with similar vectors are most likely to have same meaning or are used to convey the same sentiment. So in this video, we will be discussing two different approaches to get word embeddings. First is word2vec. So in word2vec, every word is assigned a vector. We start with either a random vector or one hot vector. Now you might be wondering, what is one hot vector? One hot vector is a representation where only one bit in a vector is 1. If there are 500 words in the corpus, then the vector length will be 500. After assigning vectors to each word, we take a window size and iterate through the entire corpus. While we do this, there are two neural embedding methods which are used. One of the neural embedding method is continuous bag of words, which is CBOW. So in this model, what we do is we try to fit the neighboring words in the window to the central word. So you can see the picture here. Input, projection, output. There is sum, there is all the respective weights has been given, and the photo has been shown here. And another model which we can use is skipgram model. So in this model, we try to make the central word closer to the neighboring words. It is the complete opposite to CBOW model. It is shown that this method produces more meaningful embeddings. So for that also we have a graph. So you can see this picture. And you can see the difference between both the two models. So after applying the above neural embedding methods, we get trained vectors of each word after many iterations through the corpus. These trained vectors preserve syntactical or semantic information and are converted to lower dimension. The vectors with similar meaning or semantic information are placed close to each other in space. Now the next thing is glove. This is another method for creating word embeddings. In this method, we take corpus and iterate through it and get the co-occurrences of each word with other words in the corpus. We get co-occurrences matrix through this. The words which occur next to each other get a value of 1. If they are one word apart, then half. If two words apart, then 1 by 3, and so on. So let's take an example to understand how a metric is created. So we have a small corpus. It is a nice evening, good evening, and it is the evening. Now when I create a corpus, you can see they are very close, so they are assigned 0. So there is nothing in the corpus where it is allocated, so the value is not given. It and is has been given the 1 plus 1 value, and it and a 1 by half plus 1, because the difference between is half, one word apart and the one word, and so on. This table is constructed. So in order to understand more clearly, the upper half of the matrix will be reflection of the lower half. We can consider a window frame as well to calculate the co-occurrences by shifting the frame till the end of the corpus. This helps gather information about the context in which the word is used. Initially, the vector for each word is assigned randomly. Then we take two pair of vectors and see how close they are to each other in space. If they occur together more often or have a higher value in the co-occurrence matrix and are far apart in space, then they are brought close to each other. If they are close to each other but are rarely or not frequently used together, then they are moved further apart in space. After many iterations of the above process, we'll get a vector space representation that approximates the information from the co-occurrence matrix. The performance of the glove is better than word2vec in terms of both semantic and syntax capture. There are even pre-trained word embeddings models. People generally use pre-trained models for word embeddings. Few of them are Spacy, FastText, and Flare, etc. Spacy we will see in the next video. And what are the common errors made in this entire process? You need to use the exact same pipeline during deploying a model as were used to create the training data for the word embedding. If you use different tokenizer or different method of handling white space, punctuation, etc., you might end up with incompatible outputs. Another thing will be words in your input that doesn't have a pre-trained vector. Such words are known as output of vocabulary, OOV. What you can do is replace those words with UNK, which means unknown, and then handle them separately. And the last is dimension mismatch. Vectors can be of many lengths. If you train a model with vector of length say 400 and then try to apply the vector length of 1000 in inference time, you will run into errors. So make sure to use the same dimensions throughout. Now, what are the benefits of using word embeddings? It is much faster to train than hand-built models like WordNet, which uses graph embeddings. And almost all modern NLP applications start with an embedding layer. Now, what are the drawbacks of embeddings? It can be memory intensive. It is corpus dependent. Any underlying bias will have an effect on your model. So this was much about the word embeddings or word vector. Now we'll implement word vector and semantics via Spacy in the next video. Thank you.